I begin this chapter by saying that sediments tell the story of the earth and what was happening at the time of deposition of the sediment. Sedimentary structures, these are like the way the sediments are deposited, really tell us about surface conditions. It can be like the way the sediment is layered can tell us about the energy. The sorting can tell us about how far the sediment has traveled. There can be ridges within the sediment that tell us the story of the movement of that sediment. Let's look at some examples. So layering or bedding or stratification is kind of all the same thing. Sedimentary bedding. And bedding, it means that there is a break between the sedimentary layers. Something has happened between those layers to change the grain size of the sediment or the color of the sediment. A whole package, a whole bunch of layers like you see here is called strata. So I would say, look at that strata. There's a bunch of different layers. The study of these layers would be called stratigraphy, and the patterns that maybe we see in the layers would be called stratigraphy. Hey, puppies. Okay. Why is there bedding? Bedding occurs because there's some kind of change. There's changes in the accumulation, and the change can be oftentimes the velocity of the water. The source of the sediment can change. The volume of water can change. The landscape use, land use can change. So humans cause a lot of movement of sediment and can cause the sediment to change. So there's going to be a change from, usually it's a velocity change of the water, and then a different sediment will be deposited. So in this image at the bottom, we have blocks where silt is being deposited, and then gravel. From a silt to a gravel, the velocity increases, and then it goes, silt, gravel, silt, and then somewhere in there, there is, the gravel is going to become the rock type conglomerate, the silt becomes siltstone, and then so you have a sequence, the strata, that is recording siltstone and gravel become a conglomerate, and then siltstone again. So fluctuations in the velocity of the movement of the water. Okay, each of those layers makes up a rock unit, and if you can take that rock unit and map it across great distances, we call that a formation. So here's an image on the left of the Grand Canyon, and on that image in here is the Vishnu. That's a schist, so it's not a sediment, it's a metamorphic rock. But on top of the Vishnu is a Tapete sandstone that makes a big plateau, the Bright Angel Shell, the Mojave, Redwall limestone, the Supai group, Hermit, Coquino, Torreep, Kaibab, back to limestone. So it goes in between some sediments that are marine and some that are terrestrial. Either way, we can map those over large distances in the Grand Canyon, and then we put them on a map. So this is just a little cropped bit of the Grand Canyon, and snaking through the middle is the Colorado River. It's flowing from right to left, and with down in the bottom of the canyon, these greens, those are really the reds and pink are granites and schists, and then above that, mimicking the topography are going to be, they parallel the contour lines because they're flat line contacts, are going to be different sedimentary layers. So each of the different colors on the map represents a formation, which are these mappable rock units. Whew. Okay, let's look at some other sedimentary structures. Here's ripple marks. So moving water, flowing water, what's flowing in one direction or oscillating back and forth, going to move that sediment into ridges. And the ridges and troughs, we call those ripple marks. On the right is also dunes. Those are like giant ripple marks. So we can have little ripples like on the seafloor. I saw some yesterday in the New River. Ignore that. Let me go get them. Okay, we're back. Okay. So that was the images of the ripples in the dunes. Here is a cartoon of that, and what it's showing is the current ripple marks are going to have a side view or a cross section where you have a long side and then a steep short side, a long side and a steep short side. That means that the current's flowing in one direction. The next box here is showing oscillation currents where the water is going oscillating back and forth. So there's going to be symmetrical ripples. So symmetrical ripples mean we have a current going back and forth. A asymmetrical ripple means the current is going in one direction. Okay. If you look at the inside of that ripple, then you have sand grains that are going to go up the backside of the ripple, and then they cascade down the front. Boop, 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 boop. That happens over time, and the ripples crawl up the back of each other. So if you layer those up over time, they look like the image here at the bottom, and these are cross beds. So these are giant dunes that have you preserving. That's the cartoon over here, just the front side or the slip face of that dune that the sand grains roll back down. So over here, the wind direction, here it is in the corner, the wind direction here is moving in that direction. Okay. That's the story the sedimentary rocks give us. Graded beds are indicative of maybe an underwater landslide. So along the continental shelf, you have steep sides along the slope and the rise. The slope, shelf, slope, rise. Along the shelf, you have a steep side, and there can be canyons cut into the continental shelf, and the material will break away. You have a whoosh of sediment out into the water column down onto the rise, and as it settles out onto the sea floor, the big grains fall first. So in these graded beds, in the cartoon here, you have 3 different events. The large grains are on the bottom, fining up to very fine grain, then another whoosh of sediment later, next day, next year, and that happens again to 3 episodes of sediment falling into still water that's not moving, and then the bigger clast falling to the bottom, and then successively up to the small clast. On the surface of the bed, the top layer, you get different things can happen to it after it's deposited and exposed. If it's a clay-rich sediment that's wet and then it dries up, those clays absorb water, and when they lose their water, they shrink and crack. So this is mud cracks. Another thing that can happen is called scour marks. This is where a sediment, like a clay, would be on the bottom of a lake or bottom of a river, and then say like a stick came through and like gouged into that sediment, gouging in and leaving a mark. That's a scour mark. Fossils are often found on surfaces. So here's some brachiopods. They can be footprints, shell impressions, traces of like where a worm was feeding in that sediment. So we can find fossils and trace fossils, just the footprints of some organism.